Hi everyone, my name is Madison Smith and this is my lab 2 charge piece of tape. So the purpose of this lab was to build off of lab 1, but instead of modeling the pieces of tape as individual point charges, we're going to model them as rods split into n different pieces so we can get a more accurate calculation for the electric force. And all of this is under the part of lab 1 where we had the top piece of tape suspended motionless floating above the bottom piece of tape. So some assumptions that I had were to treat the tape as a rod split into n equal sections where each observation location is at the center of the piece. Each piece is modeled as an individual point charge. The charges on both pieces of tape are the same. That's what I had going into my initial calculations and using the charge calculated in lab 1 so the tape would be suspended motionless. So some key principles that I had were Newton's first law. So if the forces acting on an object are balanced, then that means the acceleration is 0. So since the tape is suspended motionless, that means the forces acting on it, the gravitational and the electric forces, are going to be equal to each other in magnitude. For Newton's second law, the acceleration of an object produced by a net force is directly proportional to the magnitude of the net force. So since the acceleration is 0, that means that the net force acting on the piece of tape is 0. So the electric force and the gravitational force acting on the top piece of tape are going to be equal in magnitude in opposite directions. We also use Coulomb's law to calculate the electric force of a point charge. And we also use the superposition so we could add together all of the individual electric forces due to each piece of the rod and then sum all of those together to get the net electric force. So how is this lab different from lab 1? So we're trying to find, still trying to find the net electric force, but we're going to split it up into pieces. So we're going to break the piece of tape into equally small charged objects, find the electric field for one individual piece of the rod, and then superpose all of the electric fields to calculate the net electric field. And so we're going to calculate the net field on each top piece due to every piece on the bottom and repeat until we can superpose all of them to get the net electric field. And then once we do that, we can calculate the electric force. So this is a free body diagram of what the top piece of tape is going to look like if it was treated as an individual point charge. So we're trying to find an electric force and a gravitational force that are going to be equal in magnitude in opposite directions so that the top piece of tape will suspend motionless. So this is kind of a diagram that kind of explains the calculations behind everything. So if we're trying to find the electric field of the piece A, we're going to calculate the field due to each of the bottom pieces, and that's going to be the electric field due to piece A. So we're going to do the same thing for each piece on the top due to all the pieces on the bottom, and that's kind of what the code is going to be doing. And then after we do that for all 10 pieces, we'll get the net electric field, which is the sum of all the individual electric fields. So that is explaining what our code is doing. So each of the little green arrows are the electric fields due to each individual piece. And then as you can see, the gravitational force downward and the electric force upward are opposing and equal in magnitude. And I calculated at the bottom. I did have to change the value of our charge so that the forces would end up being equal. So the force turned out, or the charge turned out to be greater for when I calculated it using this split up pieces of a rod method. So this is also to explain the code and what all of the code is doing. So basically it's calculating each individual electric field due to all the pieces on the bottom and then superposing them and then adding in the arrows, basically doing everything that I just explained in the code form. So the mathematical calculations that were used to this to calculate the electric force. So we used Coulomb's law to calculate the electric field at each individual point charge of the entire rod using our initial values that we had from lab 1. And so once we do that, we can sum together all of the individual electric fields and then multiply that by the charge to calculate the electric force. I did have to manipulate the charge a little bit so that the forces would end up being equal. And so that is what the math did to explain what the coding was representing. And so the main takeaways from this lab were that the charge on the split up piece of tape into a rod turned out to be larger than what I calculated in lab 1 to be the charge. The value for a point charge is smaller. This is because converting a point charge to a line of charges decreases the electric force, and so due to that ratio, the Q must increase. And so doing this whole lab showed that having the electric force calculated due to a rod of individual pieces is a more accurate calculation, because with it split and distributed, you can calculate it in a more accurate way and superpose all the individual together over the entire piece of rod. Whereas just doing it for a point charge is just assuming all the charge is sitting right at the middle at a point when it's actually distributed equally throughout the entire piece of tape. And thank you for listening.